During the Second World War, and until recently, bombers required fighter escort, and the B-36 was no exception. Bomber ranges had increased, and the logistics of maintaining fighter escorts with bombers was a problem. A problem that stealth overcame by not needing escorts at all, as they had a cloak of invisibility. An experimental plane was the Goblin. It was designed to fit into a bomb bay and be carried with a bomber squadron. Should adversary fighters intercept the raid, the Goblin was to be launched to engage the enemy. The plane was not designed to land. It had a hook-type apparatus, which allowed it to be reunited with the mother plane. The plane was only 15 feet long. Its wingspan was 21 feet, and when the wings were folded to fit into the 16-foot bomb bay, the wingspan was reduced to just over 5 feet. Any dogfight would have to be of short duration, as the Goblin only carried about 130 gallons of fuel, which was only enough for 30 minutes of flight. A Westinghouse jet with 3,000 pounds of thrust was the driving force for this most tiny fighter. The Goblin's first flight was on the 23rd of August 1948. The B-36 was still to come off the production line, so a modified B-29 was used for the test flight. The B-29 could not fully accept the Goblin into its bomb bay, as would the new B-36. The release procedure was difficult and reasonably slow. The Goblin was lowered from the mother plane and simply hung there until it became stable. It then free fell away and commenced flight. The most difficult part was getting the tiny Goblin back inside the B-29. Even today, the close flying required for in-flight refueling is considered a tricky maneuver. But the tiny size of the Goblin made it very unstable, which added to the problems of the buffeting of the B-29. It proved extremely difficult to get the hook onto the lifting apparatus. A mistake here could bring both planes down. In this instance, the pilot tried to hook up with speed to keep the Goblin stable. The crash broke the canopy, and the pilot had to make an emergency landing. The pilot survived, and the Goblin was repaired. In October, the test resumed, and this time it was more successful. However, the concept of the Goblin was never really pursued much further. This is the Tomcat's second test flight. Test pilot Miller is in the rear seat, and Smythe is the pilot. The first test flight was a simple see-if-it-flies affair, and it was really only a takeoff and landing. It was uneventful. This second flight was more performance and handling based. Unlike the first flight, this one was eventful. The chase pilot noticed smoke coming from the rear of the Tomcat. A closer inspection revealed that it was hydraulic fluid. Within a few minutes, the plane started losing functions. It was basically bleeding to death. At about 100 feet above the ground, and not far away from the runway, the pilots were forced to eject and the plane, Prototype 1, was lost. And from the ground, it looked like this. This is aircraft number 12. It was redesignated as 1X to replace the lost one. This plane was to continue the test program and included the high-speed tests. Smythe Miller and the other test pilots were just coming to grips with the Tomcat, and although there were problems, it was fast becoming apparent that the Tomcat was superior to anything before it. However, at this time, the Navy and Congress were not convinced. One of the factors for their hesitation was the cost. The Tomcat wasn't cheap, and it still had problems. Throughout 1971, testing was still in progress, and the aircraft were performing better than anticipated. The teething problems were being ironed out, and the plane's sailability was looking good. This is Prototype 2 going through a routine. Several Tomcats were built with no intention of flying them. They were simply created to be destroyed in destructive testing experiments. It wasn't until June of 1972 that the first carrier tests were performed. After a series of touch and goes, a landing was completed by aircraft number 10. Another problem arose. Number 10 suffered an hydraulic leak with the nose landing gear. This is not what Grumman needed, as the Navy and Congress was still not entirely happy with the Tomcat, and this film and the result of the carrier test was to be flown to the Navy for its final decision regarding the purchase of the plane. A hydraulic leak was definitely the last thing Grumman needed. As it turned out, Congress endorsed the plane that became an aviation legend. If Congress were to have made their decision the following day, it may all have been a different story, as plane number 10 and its pilot, Miller, were both lost. The program continued, and in the latter half of 1972, production began and the F-14 entered service in 1973. The Tomcat has undergone many revamps since. In November 1987, the F-14B was released, and it incorporated new General Electric F-110 engines, which solved the engine problems of the A variant. B, C, and D variants followed, and most of the changes in these models were the weapons and defense capability of the craft. The Tomcat was the first fighter to have the remarkable Phoenix missile system. The test operation was called 6-on-6. If the test was successful, the system would prove to be a quantum leap in fighter ability. The objective of the test was for the Tomcat's pilot to attack and down 6 targets simultaneously. The targets included 2 drones, 3 training craft which simulated slow-moving targets, such as bombers, and another ground-launched drone to imitate a supersonic missile. On the radar, the 6 targets were identified and designated a prefix. From that point on, the pilot just pressed the firing button as the targets became locked on.
2's in the air. 3's in the air. 4's in the air. Check the target cameras. 4th missile in the air. Target cameras on.
At one time, all 6 missiles were in the air tracking their targets. This was due to the 50-mile range of the Phoenix. It was determined determined after retrieving the test data that with some slight modifications, the Tomcat Phoenix combination would, under combat conditions, give the pilot an 80% hit rate. The Lockheed P-3C Orion is a peerless airborne hunter. Its reputation as the ultimate submarine finder was achieved through more than 35 years of service. Today, the P-3 is still busy and remarkably well adapted for maritime patrol in the post-Cold War world. The P-3 can be outfitted with a variety of sophisticated detection equipment, infrared and long-range electro-optical cameras, plus special imaging radar to allow it to monitor activity from a comfortable distance. It can stay aloft for extremely long periods, and its four powerful Allison T-56 A-14 engines can fly at almost any altitude. In addition to sub-hunting, the P-3 is now called upon for peacekeeping and relief missions around the world. The P-3 Orion land-based maritime patrol and anti-submarine warfare aircraft is operational in the air forces of 10 countries. More than 700 P-3 aircraft have been built by Lockheed Martin. The P-3A was first operational in the US Navy in 1962. The P-3C first entered service in 1969 and has been continually upgraded and updated with new avionics systems and mission equipment. In 1975, an improved navigation system, expanded computer memory, and tactical displays were provided. In 1976, an infrared detection system and sonar buoy reference system were added, and the aircraft were fitted with the Harpoon missile. The P-3C aircraft in 1984 were equipped with advanced anti-submarine warfare avionics. During the 1990s, improvements mainly directed towards the provision of advanced signal processing capabilities, the Orions were implemented to meet the threat of new generation fast, quiet, and deep diving submarines. November 2003 saw international upgrades include new electronic support measures, radar and acoustic sensors, a new data management system, and new communication suite. The aircraft is flown by a crew of 10 on missions up to 14 hours long. The flight deck accommodates the pilot, the co-pilot, and the flight engineer. The main cabin is configured as a mission operations room for the tactical coordinator, the navigator, and communications operator. The P-3C has advanced submarine detection sensors such as directional frequency and ranging sonar buoys and magnetic anomaly detection equipment. The avionics system is integrated by a general-purpose digital computer that supports all the tactical displays and monitors and automatically launches ordnance and provides flight information to the pilots. The airborne electronic surveillance receiver is carried on a pylon under the wing fairing. The system automatically operates in search mode, its target primarily being submarine radars. The aircraft can carry weapons in the bomb bay and on 10 underwing pylons. The bomb bay is in the underside of the fuselage forward of the wing. It's capable of carrying a 2,000-pound mine or alternative ordnance, including 1,000-pound mines, depth bombs, torpedoes, or nuclear depth bombs. The underwing pylons can carry 2,000-pound mines, torpedoes, rockets, rocket pods, and 500-pound mines. The US Navy P-3C aircraft are equipped to carry the Harpoon AGM-84 anti-ship and standoff land attack missile. Once the search area has been reached, the crew usually shut off 2 of the 4 engines to extend the mission time. The 5 fuel tanks, 1 of the fuselage, and 4 integral wing tanks have a total fuel capacity of 8,900 gallons, providing range for up to 14 hours flying time. The P-3C still remains the most up-to-date version of the P-3 Orion. A successor aircraft from Lockheed was planned during the early 1980s, which would have been designated the P-7. However, a lack of funding for this project caused it to be cancelled in 1989. Thus, the P-3 Orion will probably continue on the US Navy's premier anti-submarine warfare and maritime patrol aircraft through the first decades of the 21st century. To this end, Lockheed are currently assessing the fatigue life and damage tolerance characteristics of the P-3C airframe, identifying any structural modifications required in an effort to attain the 2015 service life goal the Navy has requested. With capabilities like these, it's no wonder that somewhere above the Earth during peace or conflict, there is nearly always an Orion, serving as an eye in the sky. The F-16 began life largely as an experiment. At the time, the US Air Force did not realize that the type would become one of the most significant aircraft in its infantry. In the 1950s and early 1960s, the US military had emphasized speed over maneuverability in fighter design. The general belief was that air-to-air missiles had made dogfighting obsolete. Fighters would hit each other from long distance, well before they could get close into a turning point. American experience in Vietnam showed that reports of the death of dogfighting were premature. The new AAMs were not the miracles that they had seemed on paper, and operational realities, such as the need to confirm the identity of a target before engaging it, also limited their usefulness. The result determined the need for a supersonic fighter. Naming this new fighter posed an interesting problem. Falcon was proposed, but the Dassault Company of France was already selling a business jet with that name and objected. Mustang II was another suggestion, but Ford was selling a sports car with that name. On July 21, 1980, the Air Force announced the name Fighting Falcon. In practice, the F-16 would often be referred to by its more sinister name of Viper. The wing-body blending allows the aircraft's body to provide lift. The wing has a leading edge sweep of 40 degrees and a straight tailing edge with full span, leading edge flaps and large flaperons on the trailing edge to provide improved landing performance and combat maneuverability. Air brakes are fitted between the horizontal tailplane and the engine exhaust, with the air brakes operating top and bottom. The F-16A was originally powered by a single Pratt & Whitney F100 PW200 afterburning turbofan engine. The kidney-shaped engine intake is fitted on the belly of the aircraft below the cockpit. The positioning of the intake permits adequate airflow at high angles of attack. In 1993, Lockheed bought out the 4th Worth Division of General Dynamics, a move which was part of a series of corporate reshufflings that led to the merger of Lockheed and Martin Marietta in 1995 to form Lockheed Martin. As a result, the General Dynamics F-16 is now the Lockheed Martin F-16. Lockheed Martin acquired a valuable asset with the F-16 and has continued to refine the type. One of the features of a good combat aircraft is its suitability for improvements, and the F-16 has very much demonstrated this virtue. It is still being improved in the 21st century. The Gulf War in 1991 was the first major action for the USAF F-16s. The F-16 was assigned to the attack role during the Gulf War and scored no kills against Iraqi aircraft. But the Vipers performed large numbers of strikes on ground targets and also flew fast-forward air control missions to spot targets for other strike elements. 3 F-16s were lost in combat, and 1 was lost in an operational accident during the conflict. They played similar roles in the recent Iraqi war. With Lockheed Martin now moving forward towards production of the new F-35 Joint Strike Fighter, it is unclear just how long the F-16 will remain in production. Lockheed Martin expects to continue to build F-16s at least into 2008.